This lesson is about basic matrix operations. What's the operations? We're going to look at how to add, subtract, multiply, dividing the matrix systems. In order to get there, we wanted to know some definition of the matrix and review a little. So this matrix A, we're looking at as 2 by 2 row with 3 columns. So 2 by 3 matrix. And when it say entries, entry means they're talking about each element. This is going to be entries. Row matrix is when we have one row. Column matrix is when we have one columns. Square matrix is the matrix have the same number of row and columns. Equal matrix has the same size. So if it's 2 by 2, the other matrix is going to be also 2 by 2, right? If it's the same size, it's going to be equal matrix. In order to do addition subtractions of matrix, you have to have same size. Multiplying two matrix, the number of the column from the first matrix had to be same as the number of the row from the second matrix. So for example, if you have 2 by 3 matrix, you have to have 3 by 2 matrix where these two had to be same, right? Then you should be able to do your matrix and you will end up getting 2 by 2 matrix. So 2 by 2 matrix come out. Your solution come out from these two outside. So this gives you solution matrix. And this had to be same in order to do the multiplications. So example 1, let's start with adding and subtracting. Adding and subtracting, I need a little more space, so let's erase that. This one right here, they're the same matrix, right? This is 2 by 3 matrix, this is 2 by 3 matrix, same matrix, so we should be able to do addition, subtractions. They're asking you to do additions. When you're adding the same matrix, you're going to add the same place. So the first row, first column will get added into first row, first column from the second matrix. So you will do 0 plus negative 2. And then first row, second column, 5. We'll add it into first row, second columns, 3. So that means 3 plus 5, negative 2 plus 7, 6 plus negative 9, and negative 8 plus 6. That's why you have to have same size matrix so that you will have value to add it into each element. This will give you negative 2, 8, 8. And that gives you 5, negative 3, and negative 2. So that's how you're going to add your matrix. Let's look at the second matrix. This is 2 by 2 matrix. This is 2 by 2 matrix. So you should be able to subtract and same element, right? Same place. So it will be negative 6 minus negative 5. 7 minus 6, and 2 minus 0, and negative 3 minus negative 4. This will give you negative 1, 1, and 2, and 1, right? Negative 3 plus 4 is giving you 1. So you will end up getting this solution matrix. What about C? So I want you to try C before you watch this video. Okay, hopefully you paused it and tried. So this is 3 by 2 matrix. This is 3 by 2 matrix. So you should be able to do subtractions. And when you do 5 minus 4, you get, well, minus negative 4. That will give you 9. 4 minus 8 is negative 4. Negative 3 minus 6, negative 12. 7 minus 0 is 7. 0 minus negative 5 is adding, so it will be positive 5. 1 minus 3 will be negative 2. So that should be your matrix. What about the next one? This is 2 by 2 matrix. This is 2 by 1 matrix. So, because not the same matrix, you will not be able to do subtractions. Not the same matrix. Or same size. Okay, example 2. Let's look at multiplying real number to matrix. So this is multiplication, but just multiplying one number to the matrix. What do we do? Well, if you're just multiplying one number to the matrix, you need to make sure you distribute this like a parentheses, right? So negative 3 will be multiplied to the 2, and you will get negative 6. Negative 3 will multiply to negative 5, gives you positive 15, right? Negative 3 times 1 is negative 3. Negative 3 times 7 is negative 21. Negative 3 times 4 is negative 12. Negative 3 times negative 6 is positive 18. So that's how you're going to multiply it. When you're looking at the second one, you can either think this is multiplications of 1/2 or dividing by 2. And you need to do each element. So it will be 4 over 2, 1 over 2, 3 over 2, 2 over 2 is what you're going to do. Like dividing by 2, right? Make sure your solution should be simplest form. So reduce your fractions if it's reducible, right? So that's what you need to do. And sometimes they don't just give you a whole number multiplied by matrix. Sometimes they will say, oh, let's multiply 5 into the matrix systems B, right? And then you need to find matrix B. So different way of writing, but bottom line, they're asking you to multiply this, right? So when you're multiplying 5 times matrix B, which is 2 by 3 matrix, you need to make sure you multiply to each element. So it gives you 5, 10, 15 on the first row. Second row will be 10, 5, 5. So that's how you're going to multiply matrix with the whole number or real number. Using that, what about if we have equations, right? If we have equations like 2x plus a equals 2 times b, where A is matrix systems and B is the matrix systems. So you can either plug in as the matrix systems or solve the equation into the matrix and then solve the equation into x, and then you can work on the matrix. So in order to find this x, what do you need to do with matrix system A and B? Let's see. First, you're going to subtract both sides by A. So you will have 2b minus a. Isolate x. In order to do that, you're going to divide both sides by 2. Right? Both sides by 2. Well, let's use the different color. Then you will get x is equals to 2 over 2. This 2 cancels out. Just give you b. But then you have a over 2. So basically what you need to do in order to solve for x, you're going to divide matrix A by 2 and subtract that from B, right? So I will do that here. Let's copy the matrix B is what? 1, 2, 4, negative 1, right? And then subtract. Let's divide matrix A with 2. 2 and 3 over 2, 1 over 2. And let's see if we be able to simplify that. Only the first number, right? First number I'll be able to simplify it. That will be 1. This is 1/2. This is 3 over 2. This is 1 over 2, right? And then let's do the subtraction. Subtractions of matrix. This is the same size matrix, so you should be able to do subtractions. And each entry will be subtracted. So it will be 1 minus 1 will be 0. 2 minus 1 over 2. Well, if we work on that on the side, 2 minus negative 1/2, you have to have same denominator in order to do addition of the fractions. So this become 4 over 2 minus 1/2, which will be 3 over 2, right? Wait, hold on, you're adding. So it will be 5 over 2. So you will get 5 over 2 here. Do the same thing. So you're doing 4 minus 3 over 2. This gives you 8 over 2 minus 3 over 2. So it will be 5 over 2. And negative 1 minus 1/2. That's negative 1 minus 1/2. That will give you negative 2 over 2 minus 1/2. So that makes it negative 3 over 2. So that's what you're going to get when you're trying to solve for equations with the matrix included. Right. Let's try one more time. So what do? Let's solve for x first. If we solve for x, I will have adding both sides by 3b. Then I get x over 2 equals to 2a plus 3b. Let's multiply everything by 2. To cancel out denominator 2 and isolate x. So your x should be, multiply 2 will be 4a plus 6b. So let's see. 4 times matrix A is 2, negative 1, 3, 1. Plus 6 times matrix B is 1, 2, 4, negative 1. When you multiply the whole number into the matrix, you distribute. So it will be 4 times 2, 4 times negative 1, 4 times 3, and 4 times 1. Plus 6 times 1, 6 times 2, 6 times 4. 6 times negative 1 is negative 6. Let's add. This is the same size matrix, so you should be able to add them. So 8 plus 6 is 14. Negative 4 plus 12 is 8. 12 plus 24 is 36. 4 plus negative 6 is negative 2. So that's how you can solve matrix equations. Now, last thing we wanted to do is, are we be able to multiply matrix by matrix, right? I need a larger space, so I'm going to erase all this. Let me see, erase. Right. So remember, in order to do the matrix systems, the inner value have to be the same, then the matrix will become the same outer value. What does that mean? Okay, so this one you have 2 by 2 matrix. This is 2 by 2 matrix. So if this two number is the same, we should be able to do the multiplications, and we should be able to get the outer multiplications size. So we will get 2 by 2 matrix size when we multiply these two. So how do we do this? We will multiply this. In the first matrix, you're going to multiply by the row. Second matrix, you're going to multiply by the columns. So this is just exercise to show you how you're going to do the multiplications. So the first matrix column means you're going to use A and B, right? Well, you're going to use the row, and then second matrix, you're going to use the column, so it will be E and G. So you will do A times E plus B times G, in order to get the first column, first row and first columns. So then, in order to get the second row, first columns, you're going to do second row, so it will be C times D, and second row, first column, so it will be E times G is what you're going to do, right? So it will be C times E plus D times G is what you're going to do. In order to find the second row, first columns, you're going to do second row, wait, that's not row, second row, we're trying to get first row and second column. First row, second column, so you're going to use these two. So then you're going to get A times F plus B times H. If I wanted to get this one right here is going to be second row, second columns, right? Then it comes from second row and second columns. So that becomes C times F plus D times H. So that's the rules. Depends on which value you wanted to get. That you multiply row from the first matrix and column from the second matrix. So let's actually try the problem from B. Okay, so this is 2 by 2 and this is 2 by 2. So we should be able to do the multiplication. My solution is going to be 2 by 2. So 2 by 2 matrix. So in order to get, this is what? 2 matrix. 2 by 2, right? So in order to get first row, first columns, you will do first row, first columns. Right? I'm going to erase so I don't get confused like later, or you don't get confused. So that multiplication is going to be 1 times 1 plus 2 times negative 1, right? And if you wanted to get first row, second columns, that's the multiplication you're going to do. So it will be 1 times 1 plus 2 times 0. I'm going to erase this. And then, let's see, what else we wanted to get? We wanted to get now second row, first columns. So you will get negative 3 times 1 plus negative 2 times negative 1. And let's find the last one, which is going to be second row and second columns. So that will be negative 3 times 1 plus negative 2 times 0. then my matrix will be negative 1, 1, negative 1, and negative 3. What about this one? C. The first thing I wanted to do is making sure there is the inner values are same. Like this is 2 by 2 inner value, right? You have to have same inner value in order to do the multiplication. So this is going to be 2 by 3 matrix. This is 3 by 2 matrix. So because this 2 is the same value, we should be able to do the multiplications. And your solution matrix is going to be 2 by 2 matrix. Okay. So then I can build my matrix. And I will have what? I don't want it to make a box. So I will have 1, 2, 1, 2. 2 by 2 matrix, right? So first one, I will use first row and first columns. That's what this place is, right? So I will do negative 3 times negative 6 plus 4 times 2 plus 2 times 3. And then if I wanted to get, you know what, I can just leave it as it is. Let me just use the different colors, right? So if I wanted to get first row, second column, I will do first row multiplied by second column from the second matrix. So it will be negative 3 times 4 plus 0 times 3 plus 4 times negative 2. And then let me do second row, first column. So second row, first columns is going to be right here. So it will be 5 times negative 6 plus 0 times 2 plus 4 times 3, right? And then let's see what else color I have. Let me use the green to get the second row, second columns. So second row, second columns, I will get 5 times 4 plus 0 times 3 plus 4 times negative 2. Then I will get my matrix. That will be 18 plus 8 plus 6, which gives you 32. I will get negative 12, that's 0, and plus negative 8. So that gets negative 20. And this is negative 30, 0, and plus 12, so it will be negative 18. This is 20 minus 8, so it will be 12. So I do have 2 by 2 matrix, 2 by 2 matrix. So that's how you're going to do your multiplications. The next examples, I wanted to show you, if you look at this D problems, you can see it's the same matrix, but flipped, right? Same matrix flipped. In a multiplication of the natural number, whole numbers, if you do 2 times 3, it's same as 3 times 2. You can switch the order, you will still get the same answer, 6, right? But matrix system, when you flip them, you will not get the same matrix. And that's what I wanted to show you on D. I'm assuming by example D, you know how to do the multiplications, understanding how to do the multiplications. But this one I wanted to show you. This is 3 by 2 matrix. This is 2 by 3 matrix. So I'd be able to do the multiplications. But my solution is going to be 3 by 3 matrix. 3 by 3 matrix, not 2 by 2 like the other ones. So definitely I will have different matrix systems. So let me just do this. This is row and this is column matrix. So the first, I will do negative 6 times negative 3 plus 4 times 5. 3 by 3 matrix. So it'll be 1, 2, 3, 1, 2, 3, 1, 2, 3 matrix. And then first row, second column will be negative 6 times 4 plus 4 times 0. Negative 6 times 2 plus 4 times 4. This is 2 times negative 3 plus 4 times 5. 2 times 4 plus 3 times 0. Make sure this is 3. This is 2 times 2 plus 3 times 4. And this is 3 times negative 3 plus negative 2 times 5. 3 times 4 plus 2 times 0. 3 times 2 plus 2 negative 2 times 4. So that my matrix will be 2, negative 24, 4, 14, 8, 16, negative 19, 12, and negative 2, right? That's what I get. And you can tell this is quite different matrix systems, even though we're using the different matrix multiplications and flipped. Okay, so that's what I wanted to show you. The next example is same thing. We're doing a multiplication, but they can just name the matrix and they say multiply matrix A times B, right? You could also do that. Same thing. If it's the inner multiplication value is the same, you can do the multiplications and you will get outer matrix systems. Okay. So when we're looking at F, this is going to be matrix B times matrix A. So when we write it, we'll have 1, 0, negative 1, 3, 1, 4 multiplied by 1, 7, negative 3, and 2. Are we be able to multiply? Well, I don't know. This is going to be 2 by 3 matrix. This is 2 by 2 matrix. This is not same. So we cannot do multiplications. Okay? Because these two numbers had to be same in order to do the multiplications. Hopefully, you'll be able to understand how to do the multiplications or any simple operations, right, of matrix. If you have any questions about different matrix systems, you can email me and then I will send you the video to explain.